Yes, uh, today we will start new chapter, second chapter, units and measurement. As we have discussed various physical quantity and physical world and significance of a study of physics in our day-to-day life. Now, today we will discuss new topic, units and measurement. And let us have a brief introduction about the topic that this chapter includes. First one is physical quantity, and subtopic in this main topic will be fundamental and derived physical quantity. Thereafter units, and then fundamental units and derived units, and characteristics of standard units, and system of units like FPS system, CGS system, MKS system, and SI system of units. After that, definition of fundamental SI units, and then measurement of length, including large and small distance, measurement of mass, and measurement of time. And after that, we will discuss about the significance of accuracy, precision of instrument and errors in measurement, systematic error, this is types of error, systematic errors and random error, and then absolute error, relative error and percentage error. After going through all these topics, we will discuss about the transmission of error. That is, error can be transferred in mathematical operation, in addition, subtraction, multiplication, division, and exponential operation. After that, significant figure, scientific notation, and round off uncertain digits, etc. And then important topic, dimension, dimensional formula, and dimensional equation. Dimensional analysis and application of dimensional analysis, and its merits and demerits. All these topics together, there are 14 topics in these chapters and various subtopics inbuilt there. So first of all, let us discuss about what is physical quantity. We know that physical quantities are those which can be measured and has certain specific unit for its measurement are called physical quantity, like mass, length, time, current, volume, and density, etc. Now, that means physical quantities can be experienced in day-to-day life. So we can say that all the things that can be touched or that are which are materialistic are physical quantity, and like feelings, emotions, all these are not a physical quantity because these things cannot be measured and has no specific unit for its measurement. So emotions and feelings are not a physical quantity. Now next one is that we have to divide physical quantity in two categories. One is fundamental physical quantity and other one is derived physical quantity. A fundamental physical quantity are those which cannot be derived from any other physical quantity and is self-defined. That means it cannot be expressed in terms of any other physical quantity. It is self-defined and self-existing. So these are called fundamental physical quantities. There are 7 fundamental quantities altogether in our physical world. As for example, length, mass and time, etc. Out of 7 fundamental physical quantities, these are the fundamental quantities. Length, mass, time, temperature, current, and amount of substance, luminous intensity, all these are 7 fundamental physical quantities. Now, what about derived physical quantity? Derived physical quantities are those which can be derived or extracted or expressed in terms of fundamental physical quantity is called derived physical quantities. As for example, speed, velocity, acceleration, force, momentum, torque, energy, pressure, density, thermal conductivity, resistance, magnetic moment, etc. All these are derived physical quantities because in order to realize this one, as for example, a speed, you define a speed as ratio of distance traveled per unit time, or you say distance traveled divided by time taken. So distance is fundamental quantity and time is fundamental quantity. So in terms of two fundamental quantity, a speed is expressed and defined. Therefore, a speed is not independent physical quantity, but it depends on length and time. That's why it is dependent physical quantity and derived physical quantity. And in order to derive a speed, we need two fundamental physical quantity, time and length. Similarly, for acceleration and force, for force, you know that force equal to mass into acceleration. So mass is one of the fundamental quantity and acceleration consists of two fundamental quantity, time and length. Therefore, force is depending on three fundamental quantity. Therefore, force is not a fundamental quantity, but it is derived physical quantity. Now, so far we have learned about physical quantity. Now we need some measuring activities to measure physical quantity, because we have already defined that all those quantities that we see around us are said to be physical quantity which can be measured. A measurable things are categorized as a physical quantity. So in order to measure it, we need most essential thing is unit. You know well that measurement is the process of comparison of a physical quantity with certain given standard of exactly same nature as that of the given physical quantity. So, first of all, we need unit, that is certain standard chosen for the comparison in order to measure a given physical quantity. That standard is called unit. So, in order to understand unit, let us first show units for measuring a physical quantity is basically units standardized the measurement of a physical quantity. Units standardize the measurement of physical quantity, and they let us know what property is being measured, and they provide a point of reference for magnitude. This is the advantage of having units. As for example, meter is the unit of length, a standard unit of length, and that can be used as SI unit. So, and this standard unit further subdivided into a smaller one, say centimeter, 1 meter is further divided into 100 equal parts, and each part is called centimeter. And centimeter further divided into 10 equal parts, and each part is called millimeter. So we see here unit basically provide us the facility and standardize the measurement of physical quantity, and let us to know what property is being used for measuring, and also provides point of reference for magnitude. As for example, here various units are given for measuring length. One standard unit is meter, and then second a smaller one is centimeter, and even more smaller than millimeter, and another units are yard, commonly used for measuring length, and British system of unit for measuring length is feet. So 1 meter consists of 3 feet of length in it, and next one is inches. That is, there are 12 inches in 1 feet. The metric units follow power of 10, and there are 100 cm in a meter and 1000 mm in a meter. So this system of units even are said to be metric system of units. The English units have less predictable relationship. That is, British units have less predictable relationship. So there are 3 feet in a yard, and 12 inches in a foot, and 36 inches in a yard. These are the relation between various units for measuring length. Now check out here, metric units or metric system of unit was first designed to be a unified and rational system of measurement, and the metric system improves calculation, communication, and conversion. So amazingly, it has been adopted by almost every country on this earth. So we can say that this metric system of unit is nowadays being used worldwide. Now, unknowingly, United States have chosen to not fully adopt the metric system, but the American sciences do use metric, and we use metric units on this site. So basically, let us check out metric system. What is metric system of unities? Metric system, this is the features of metric system of unit. It defines all the units from the 7 fundamental units, and the base units come from the measuring physical constant. For example, the meter is defined as the distance light travels in 1/299,792,458 seconds. So here we have table of 7 fundamental physical quantities along with their units and their name and symbols. So look over here. Time is one of the fundamental physical quantities. Length is another fundamental physical quantities. Mass is a third fundamental quantity, and electric current is fourth one fundamental quantity, and temperature is fifth one fundamental quantity, and amount of substance is sixth one fundamental quantity, and intensity, luminous intensity or intensity of light is seventh fundamental quantity, and names of their unit, fundamental units, names of their corresponding fundamental units, and names of units of fundamental units of corresponding fundamental physical quantities. Time has fundamental unit second, and it is symbolically denoted as a small s, and length has fundamental unit meter and symbolically denoted as small m, and mass has fundamental units kilogram and symbolically it is denoted by kg, and current has fundamental unit as ampere and it is denoted by capital A because this ampere is the name taken from the name of the scientist, so that's why its symbol is denoted in capital. And temperature has fundamental unit Kelvin for its measurement and it is denoted by capital K because Kelvin was also a name of a scientist. And amount of substance has fundamental unit mole, MOLE, and it is symbolically and abbreviated as MOL. And last one is luminous intensity or intensity of light. It has fundamental unit candela and it has a symbol C and D. CD is a symbol. So now come to the point. Derived units are combination of these base units or fundamental units. If we know the 7 fundamental units of the 7 fundamental physical quantities, then we can give the units of the derived physical quantities by with the knowledge of the fundamental quantities involved in the expression of derived physical quantities. For example, velocity is the combination of length and time, and mathematically it is expressed as length divided by time. So SI unit of length or fundamental unit of length is meter and fundamental unit of time is second. Therefore, derived unit of velocity is meter per second. So this is called derived unit. So other than 7 fundamental quantities, rest physical quantities are said to be derived physical quantities, except there are 2 supplementary physical quantities, plane angle and solid angles, that we will discuss here. So look at here. Other than this 7 fundamental quantity, now we are having another physical quantity. So you see here area, volume, velocity, acceleration and momentum. These are physical quantities, but we cannot say these are fundamental quantities, fundamental physical quantities, because area depends on length and length. So when you multiply length and length, you get area. So area depends on 2 fundamental quantities, length and length. That's why area is not a independent physical quantities, but it is derived physical quantity, has been derived from fundamental quantity like length, and its name of unit is meter squared and symbol is m square because symbol of meter is m, so m into m equal to m square. Now similarly volume is derived physical quantity, so its unit name is meter cubed, and symbolically it is written as m to the power 3. Velocity is a derived physical quantity and it has unit name meter per second and is denoted as m oblique s. Acceleration meter per second squared. So here meter per second squared, and momentum kilogram meter per second, that is kg meter per second. So some derived units get a special abbreviation, normally written as a capital letter. For example, the unit of force is Newton, but it stands for kg meter per second square. So you see here, force is a physical quantity and it has unit name Newton, while writing full name of unit Newton, we must start with a small letter, but when it is abbreviated, then it must be written as capital letter because Newton is the name of a scientist. And in symbol, it is denoted as kg meter per second square, and this kg meter per second square itself is called Newton. Energy has unit name joule, and this has been taken from the James Prescott Joule, a name of scientist. So it is also abbreviated as capital J, and its traditional unit, or you can say that we derived from mathematically, is kg meter square per second square. And next one, power. Power has unit name watt and is denoted by W, because watt is also a name of a scientist, James Prescott Watt. So this is symbolically denoted as W, and kg meter square per cubic second. And frequency has unit name Hertz, HERTZ, and it is abbreviated as HZ. H is capital because Hertz is a name of scientist. And similarly, SI unit of volume is liter, and is symbolically it is denoted as capital L, and 1 liter equal to 10 to the power minus 3 cubic meter. So we have discussed about units, and unit measurement of any physical quantity involves comparison with a certain basic arbitrarily chosen standard and internationally accepted reference standard called units. We have defined units, and we have already told you that units standardize the measurement of the properties of given physical quantities. So here fundamental units, let us first talk about the units of fundamental or base quantities are called fundamental units or base unit. And for example, length, mass and time are fundamental physical quantities. So unit for measuring these physical quantities are called fundamental units. And thereafter derived units of physical quantity which has been derived from the fundamental quantity and can be expressed from the base or fundamental quantities are called derived units. As for example, meter per second is the unit of speed or velocity, and kg per cubic meter is density, and kg meter per second square is basically force. So it is a force. It is a force. Yes. Now, now we have to know about the system of units. A system of units is defined as a complete set of both fundamental and derived unit is known as system of units. And let us check out what is characteristics of system of units and standard units. A unit selected for measuring a physical quantity must fulfill the following requirement. Then that unit could be a standard unit for measuring that physical quantity. First one is here. It should be a well-defined. A standard unit of a given physical quantity must be well-defined. It should be of suitable size. That is, it should be neither be too large nor too small in comparison to the quantity which is to be measured. Third point is that it should be reproducible at all the places. That means it must be available everywhere and reproducible at all the places worldwide. And it should not be, it should not change from place to place or time to time. That means a standard unit must not depend on the physical condition like pressure and temperature. And it should not change with physical conditions such as temperature and pressure, etc. And it should be easily accessible everywhere. Then unit become a standard unit. Now let us discuss about various system of units in earlier time. Various system of units like FPS, CGS and MKS. These are the system of units. As we have already discussed, what is system of unit? A complete set of both fundamental and derived units are known as a system of units. So we have now various system of units. FPS stands for foot, pound and second. CGS stands for centimeter, gram and second. And MKS stands for meter, kilogram and second. So these are the three system of units were used for measurement in the earlier time, and they were named so from the fundamental units in their respective system as given below. So try to understand here. Here physical quantity is length and its dimension is L, that will be discussed later, and its unit in FPS system is foot and its unit in CGS system is centimeter and its unit in MKS system is meter. Similarly, mass is a physical quantity and its dimension is capital M, and name of its unit in FPS system is pound, and name of its unit in CGS system is gram, and name of its unit in MKS system is kilogram. Now come to the point. Time. Time is a fundamental quantity and its dimension is capital T, and its unit name in FPS system is second, in CGS system is second, in MKS system is also second. So time has same unit in all the system. Now let us understand it well. FPS stands for foot, pound, second. That means FPS is a system of unit, or it is a British system of unit in which length is measured in foot and mass is measured in pound and time is measured in second. Similarly, CGS system of unit, it is a system of unit in which length is measured in centimeter and mass is measured in gram, and time is measured in second. So here C for centimeter and G for gram and S for second. Similarly here F for foot, P for pound and S for second. Now come to the point MKS system of unit. It is a system of unit in which length is measured in meter and mass is measured in kilogram and time is measured in second. So here M stands for meter and K stands for kilogram and S stands for second. Now apart from these system of units, now we are going to deal with the another system of unit which is internationally dominant, and nowadays uh, it is used dominantly worldwide. So system international D unites is called abbreviately or is abbreviated as SI units. You know here, system international D unites. In French language, international system of unit can be written as system international D unites. As we know that international general conference on weights and measure is situated in Paris, that is capital of France. Therefore, in French language, international system of unit can be written as system international D unites and hence abbreviated as SI units. The SI system of unit with a standard scheme of symbols, units and abbreviations was developed was developed was developed and recommended by General Conference on Weights and Measure in 1971 for international uses in scientific, technical, and industrial and commercial work. And this is the system of units which is at present accepted worldwide or internationally. SI system uses decimal system and therefore conversion within the system are quite simple and convenient. That's why SI system of units are more popular in comparison to any other system of units. We see here fundamental units in SI system of units. So here name of physical quantity is given. There are 7 fundamental physical quantities: length, mass, time, current, electricity or electric current, and thermodynamic temperature, and light intensity and amount of substance. So these are the 7 fundamental quantities. So let us check out the symbol of the fundamental quantities. Length has symbol capital L. This is the symbol for physical quantity, fundamental physical quantity. As length starts from L, that's why here capital L is the symbol of length, and mass capital M is the symbol of mass, and time capital T is symbol of time, and electric current capital A here is the SI unit of current is ampere, so symbol of electric current as a physical quantity is A. And now thermodynamic temperature has K because Kelvin is the scientist who deals with the temperature and research a lot. Next, luminous intensity or intensity of light has symbol of unit CD, that is capital C and a small d, because it is Candela was a scientist, so symbol of this now here amount of substance is symbolically denoted as MOLE, and now come to the name of their units. Length has SI unit meter, so name of unit of length in SI system of unit is meter, and that of mass in SI system of unit is kilogram, and that of time is second, and that of electric current is ampere, and that of temperature is Kelvin, and is of luminous intensity or light intensity candela, and amount of substance MOLE. Now we know we have to know about the symbol of the unit. So meter is symbolically denoted as M, and kilogram is symbolically denoted as kg, and that of second is small s, and that of ampere is capital A, and that of Kelvin is capital K, because ampere and Kelvin is the name of scientist, and that of candela is a small c and a small d, because in dimension we write here capital D. And now come to the mole is denoted as MOL. And apart from these 7 fundamental quantities, there are 2 supplementary physical quantities and named as plane angle and solid angle. And plane angle is denoted by theta or d theta. You know well, you are in the habit of using theta as angle, even in trigonometry and geometry. And this is ohm, symbol of ohm, d omega. This is the solid angle. So SI unit of plane angle is radian and is abbreviated as rad, RAD. And SI unit of solid angle is ST radian and is abbreviated as SR. Now next topic is to be discussed, that is definition of SI units of fundamental quantity, because there are 7 fundamental quantities. So SI unit of each and every fundamental quantity must be well defined, and thereafter we will discuss about derived units. So for today this is all about, and next day we will discuss the definition of fundamental units. Till then, keep reviewing this. This will be uploaded on YouTube.